So, Dr. Bart, let's take a look at Unit 1, where we have Lesson 2 on user interaction, just to give folks an idea of what the resources are that are available for educators to use in the classroom, as well as for students to engage with.
Yeah, great. So right here, we're looking at some of the slides, which is one of the resources provided by Microsoft for this platform. These slides have all the extra things that you're going to need in order to teach it in an actual classroom environment. So it has an overview of what the students are going to be learning that week, along with actual learning objectives, which are synced up with things like the CSTA standards. And these are at the beginning of each of the slide decks, along with other sort of supplementary information. Now, if we go into what the slide decks have, it's got a sort of retelling of the same text from the online platform in a way that is nice for presentations. So like right here, we're in the second lesson where we're talking about the phases of a program: input data coming in, data being processed, and then data leaving. And there's a whole metaphor here with baking, where you've got the ingredients coming in, you do the mixing, and then you end up with a delicious cupcake here at the end. So I would spend some time with my students talking about this, going through this particular concept, and I go on to the next slide where I could also have an example of types of input, which would be the next part of that lesson. So you see, for each of these, there's the content and also some nice, beautiful images that they've created for this material. We talk about different examples, input types. So for instance, the data coming from a mouse moving, or a keyboard being typed, or data coming from a Wi-Fi device, or a sensor over the internet. Data come in through all these different places in a program. And I might even have my students sort of talk out loud, like, oh, what are some other examples of where data can come from, or more specific things, more exotic things, getting them to think outside the box. But I also might just have them move on directly to the next part of this, which is embedded throughout this presentation, this slide deck, are these check your understanding questions. These are really great. I think that they have a lot of value for sort of keeping students engaged. If they're not biting on my discussion, I can have them do these instead. Sometimes I'll use something like Poll Everywhere or something to administer them. But for example, right here, I ask, like, which of the following is a way of getting input from a user? And I might have them do think, pair, share approach to have them work together to talk about it, or I might just have them respond individually. But whatever I go with, when we're ready to talk about the answer, the very next slide will actually show the correct answer marked off like that, along with a bit of feedback. So this is the experience that you can give them in the classroom using the slide deck, with these check your understanding questions embedded throughout. And then, of course, at the end, there'd be a summary and everything. Now, let's also take a look at what this looks like in the environment, the VS Code for EDU tool itself. Okay, so notice here we're in VS Code EDU, and it's got the same kind of content that we saw in the slideshow. So the same text and the same images, just with a little bit more detail in the text. And if we scroll further down, you can see that we've got these underlined keywords. We've also got at the very bottom a check your understanding question, the same one that we saw from the slides. So in this, a student can click on one of the options and then click check your answer in order to get feedback, not only when they get it correct, but also if they choose one of the incorrect answers. And this can go into a bit more depth than the class-wide discussion. So there's a few different ways that you can actually use this in a real-world classroom environment. So on the one hand, you could have them totally disentangled from each other, completely async, where the students are completing this outside of class, and then you have either a lecture independent of the tool or just different lecture entirely. But what you can also do, which I think can be very effective, is have the students going along with your slides in the textbook. That way, if they miss anything, they've got it right there, and answering the questions right there in the environment and getting the same kind of feedback. So there's a few different ways that you can use the tool and the slides together.
So we're taking a look now at a code challenge called Now You Print, which is also in Unit 1, Lesson 2. Dr. Bart, can you take us through kind of the code challenge concept, and then also about what's happening in this one? I will be the student
Absolutely.
in this case, typing, and maybe making some errors here and there.
Absolutely. So these code challenges come in the book, and they are opportunities for the students to practice writing programs and getting feedback on those programs when they run them. Now, this one's a very early one. It's covering just some of the most basic concepts, just trying to print out text to the user and to see that output. So it gives you an example first of like, hey, this is how you use the print function in order to write some text. And then it asks you further down in it to write something more specific. So if you wouldn't mind writing some text, but perhaps it would be interesting, yes, if you could make a mistake just like that. You see, immediately the environment, VS Code EDU, is giving you the IntelliSense feedback right there with the red squiggles, that immediate feedback for your students. And if you hover over it, it will give more information about what's gone wrong, saying like, oh, the string literal is unterminated, just like you would in a regular VS Code environment that the professionals would be using. And they can offer suggestions and more detailed advice about like, oh, hey, you opened the parentheses, but you didn't close it, or in this case, actually, that it's missing a quotation mark. So the students can also, if they're getting confused by any of that, try running the code, and then it will pop up in the terminal with the output from our pedal tool. And you see it gives some context saying, hey, we ran your code. There was no output in this particular case because here's some feedback, you got a syntax error. And it's going to show you the actual original Python error down below, but it's also going to try and offer you some explanation of what went wrong from its perspective, what it can tell you. We're always working on trying to improve this kind of output because it's the ongoing project related to pedal. But the goal here is to try and explain in more detail, like, hey, maybe here's a suggestion or some more details about what we can tell from looking at your code. So if you go in there and you try and solve the problem, fixing the quotation mark, you notice that he's made a very small intentional mistake here. When he tries running it, it's going to give him some feedback. This time there's no red squiggles because there's no error, but there is something wrong with the code. You can see that the output is there, so it was successfully executed, but it wasn't correct according to the specification, the instructions of writing, this is programming with an exclamation mark. And the pedal tool has been configured for this problem to actually tell him like, hey, you know, you missed the exclamation mark. I know the instructions say to do it, so you have to practice this because it's really important to be precise while you're coding. So once they manage to get the exclamation mark at the end and then run their code, then this time when it gets the feedback, which you see is fairly fast, that says your code ran successfully, great work, you're ready to move on to the next page using the next button. So you can get all this feedback right here in your environment.
And one thing to note on this also is on the left-hand side in the table of contents, we have these circles that are filled in and empty. It's actually doing, through that validation, gating and saying that this is now unlocked and that the student has completed that coding activity. You'll notice that the summary at this lesson level as well is locked until students complete all of the elements that are part of that individual lesson. So these code challenges act as another form of this formative assessment along the way that students are doing across the lessons. Thank you so much for showing us that, Dr. Bart. Appreciate it.
Okay, so we just saw how that looked in the environment, but you see that the slides also have the same code challenge in it. So here it's now you print, we're asking them to try printing your own program. And in addition to having the text here, we'll also have the solution slide right up there for the instructor. So if you want to be having students work on this individually on their own desks, that's one sort of strategy. Let them work on their own for a while, either in the environment, or you can then also show them the answer once you're ready for the class to sort of move on without needing to add anything else because it just comes in the slides already for you.
On behalf of Dr. Bart and the VS Code for Education team, I want to thank you so very much for joining us for Python in Your Classroom, Enhancing Teaching and Learning with VS Code for Education. If you have any questions, would like to engage us with more ideas or suggestions that you may have, we invite you to join us at our community, available at communities.vscodeedu.com, or by sending us an email at code-edu@microsoft.com. Again, it's been a pleasure, and we hope you have a wonderful day. Thank you so much.